Let's start with the logarithmic function. We know that the exponential function. What is exponential function? B raised to x is equal to a, where b is greater than 0. Is it? Let operate log on both. Log. So what we get? Log b raised to a is equal to x. Is it? So what it means? The x. What is x here? It is x is a exponential power of an exponential function. So what logarithm function gives? Logarithmic function gives the power of x. Is it? Again, b raised to x is equal to a. If you operate log, then all it becomes a will go on that side, x will be here. What is x? If you see, x is the exponent power of an exponential function. So in short, we can say logarithmic function gives the power of x. Is it? For example, 2 raised to 3 is equal to 8. If you operate log, then log 2, 8 will go there, will be equal to 3. What is 3 here? Power of an exponential function. Now question arises, can the logarithmic function be negative or not? The answer is no. How? You say 2 raised to 4. 2 raised to 4 it become 16. 2 raised to minus 2 raised to minus 4 will become 1 upon 16. Now if you operate log on both the sides, so what you get? Log 2 is equal to 1 upon 16 is equal to minus 4. Is it? So logarithm function can never be negative. Now analyze this. What are these functions? Is it? What is the value of all this? B is greater than 0. A can never be negative. We just now understood. It is 1 upon 16. From this example, we can understand that A can be never be negative. Is it? So A is always positive. B we know that it is greater than 0, and x, yes, x can be positive, negative, or it can also be 0. Is it? So if we talk about the logarithmic function, so log b, where is a? A is a positive, is it? So r plus. And what is x? X can be positive, negative, 0, so it is up to, it is 2r. So logarithmic function, is it? It is r plus 2r. Okay, what we substitute? We substitute here the value. What is here? Suppose we say that log b raised to x is equal to y. What is x here? We substitute the value 1, 2, 3. So the x is the domain, and which is the value of x. Is it? So here we substitute 1, 2, 3. What is here? It is r plus. So x is the domain. So domain is the value of x. So what is the domain? Domain is the value of x. And what is x? We know that here we taken a, which is can never be negative. It is always positive. Is it? So we can say that x domain is the value of x, and r is always positive, r plus, and x is always positive. What we get? Substitute here, we get range. So what is a range we get? Range can be, it is x. Is it? If we operate here, what we'll get again? b raised to y is equal to x. X is what? Is it? Okay. So what we get? The range. We get a range. After substituting the value of x, we get a value of y, which is a range. Range can be r. Is it? It can be r only. Okay. So let's draw the graph of a logarithmic function. Say suppose you take it as take it first log 10 raised to x. If it is log 10 raised to x, if x is 1, so then we get log 10 raised to 1. 10 raised to 1 is 0, so implies y is equal to 0. So where is the point? Point is here, 1. We can say it is 1, 0. Is it? So every logarithmic function will pass through 1, 0. So it is always will pass through 1, 0. Let's take x is equal to 10. X is equal to 10, then log 10 upon 10. 10 upon 10. Base and powers are same. So what is that? It is equal to 1. Is it? So when 10 it is 1. Is it? When it is 100, 100 means what? 10 raised to 10 raised to square. So log 10 raised to 100, it is log 10 raised to 10 into 2. So 2 will come in multiplication. So log 10 raised to 10. 10 raised to 10 is what? 2. So what we get? 2 here. So if you draw for the log 10 raised to x, will pass through this one. This is the curve. Got it? Okay. E raised to x. If you take e raised to x, it will further will pass through this and become stiffer. Okay. Will pass through like this. See from here. Okay. We'll take log 2 raised to x. As the base is decreases, it will the logarithmic function, the graph will become more curve upside. Is it? So log 2 raised to x, log 2 raised to x will pass through this one. Okay, understand? Now let's see. When x is equal to 0, when x is equal to 0, what is log 10 raised to 0? 10 raised to 0 will be infinity. So it means that if it is x is equal to 0, it will pass through the infinity. It will never become 0. Is it? It will pass through here, but it will never become, it will never touch 1. It will be 10 to 0, but it will never become 0. It can become negative. It is minus infinity, but it will never touch this y minus negative y. Is it? Yeah, understand? So when x tend to 0, then log 10 raised to x is 10 to minus infinity. Okay, this is about the log. Now there are two types of log. Natural log. Natural log is represented by log e raised to x, which is equal to y. So when e is there, it is always represented as natural log. And in NCERT book, it is never written as e, but it is normally written as log. Is it? Okay, it is written as log, not log e. When log it is written, it is understood that the base is e. And log e raised to, or says for example log e raised to x is equal to y, it is denoted as L and x. In physics it is written as log. It is written, natural log is written as L and x. X is this, so it is L and x. Is it? And common log is what? Log 10 raised to x is equal to y. This is 10 raised to base, it is called a common log. Okay, is it? Whenever there is a common log, it is base is always written as 10, which is called a common log. Let's take e raised to x. What is e raised to x? It is an exponential function. Okay, and operate log. So log e raised to y is equal to x. This is a logarithmic function. As I explain you that exponential function passes through 1 0. Got it? X is equal to say 1 0. Is it? X is no, sorry, it is 0 1. Exponential function always pass through 0 1. Is it? X is equal to 0 and y is 1. You know that this is exponential function, and this also, as I explained before, the exponential function is also never become 0. It will tend to become 0, but it will never become 0. Okay, understand? And just now we studied about the logarithmic function. Logarithmic function passes through 1 0. X is equal to 1 and y is 0. So it is passes through this here. So if we compare the exponential function graph and the logarithmic function graph, and we take this line we know x is equal to y. Is it? This line passing through 0 0, it is x is equal to y. Is it? So this act as a mirror. So what is that? Exponential function and the logarithmic function are what? Mirror image of each other. Is it? Are the mirror image of each other. That is that. Okay, understand? So what we study? The exponential functions, it is always pass through 0 1, and the logarithmic function will pass through 1 0. And if we take this as this is line passing through origin, which is equal to x is equal to y. So this will act as a mirror image. So what we can say, conclude that we can conclude that the exponential function and the logarithmic functions are mirror image of each other. Is it okay? So let's study the properties of logarithmic function. This is very much important. First is change of base. See, log a raised to b. How we can say, if we put e, then the b will come up. So log e raised to b upon log e raised to a. Is it okay? Again, log a raised to b. How it can be? Change the base. We can change the base as log e raised to b upon log e raised to a. For example, let's take here log 7 raised to x. So what we'll write? Log e raised to x upon log e raised to 7. What is e raised to x? Normally, just I told you that e raised to e is never written. It is normally written as log x. What is the derivative of log x? 1 upon x. And what is the derivative of log 7? It's constant. It is a constant. It's same as. Is it? It remains same. So 1 upon log e raised to 7 into 1 upon log x. Log x is 1 upon x. So if you simplify, what we get? 1 upon x is equal to log e raised to 7. Now first, second one, the log of product of a number of a function. So log e raised to mn can be written as log e raised to m plus log e raised to n. This is very much important. Is it? When it is in plus sign, we cannot write in into. Reverse is not possible. Is it? And whenever there is a plus sign in between, it is into, then we can write it is in plus. But if it is in plus and minus, we don't have any formula for the log. We cannot apply log. Log can only be applied if it is into m and m into n. So log e raised to n is equal to log e raised to m plus log e raised to n. For instance, suppose it is given log e raised to 7x plus 8. We cannot write 56. It is log 56. Reverse we cannot write. It is wrong. Okay? Understand? Even log m plus n cannot be written as m log m plus log n. This is also wrong. Because if it is into, then we can write in plus. If it is a plus, we cannot apply distributive property in the log. Is it? Okay. So this has to be careful. You have to be very careful about this law. Only multiplication is there, then only we can apply log and write plus sign. If it is a plus sign, we cannot apply distributive property of log and write it. Is it? And neither, if it is a plus, we cannot write in multiplication. Reverse is not possible. Let's move on to third rule. Log e raised to mn. It is equal to log e m minus log e raised to n. Here also reverse is not possible. Now log e raised to mn, is it? It will come in multiplication n log e raised to m. For example, let's take example e raised to 4. Is it? 4 can be written as 2 raised to 2. Is it? So what will become 2 into log e raised to 2. 2 into log e raised to 2. Is it? We know that e raised to e is 1. A raised to e is also 1. 10 raised to 10 is also 1. Let's take 5. One more example. E raised to log e5. Is it? It is 5 because e raised to log e is 1. So it will become 5. Okay. Understand? You have to remember that e raised to log e is whatever its power is that it will be equal to 1 because it will be equal to 5 or equal to x because e raised to log e is 1. For example, again you take e raised to log e raised to x square. What is e raised to log e? It is 1. So this is equal to x square. Okay. Take example e raised to 2 log e raised to x. So this power can come in multiplication. So again it can be put into the power. So what we'll get? Log e raised to log e x square. Is it? But e raised to log e is 1. So again we'll get x square. For example, again e raised to 3 log e raised to x. So this can be move to the power. So I'll get log e raised to x cube, which is equal to x cube. It can be inverse also. Is it? If it is given that e raised to log e raised to cube, so it can be written as 3 e raised to log e raised to 3 log e raised to x. Is it? Inverse also possible. So let's take example here. Let y is equal to x raised to x. Now we can apply log. Is it? Wherever the function is exponential form, we can easily apply log. So log function are seen whenever there is an exponential function like this. Is it? So apply log. So log e raised to y is equal to log e raised to x raised to x. So it will come in multiplication. Is it? So log e raised to y will be x log e raised to x. Okay, now we can differentiate on both the sides. See, this is x into y, x into y. Here log e raised to x. Is it? Here first, according to the log function, you have to take derivative. What is a log y? Log y is 1 upon y. And then y. What is a y? dy by dx is equal to, now x as a constant and derivative of 1 log x is what? Log x is 1 upon x plus x log e raised to x a constant and derivative of x is what? 1. So we'll get 1. Okay, understand? So dy by dx, this will come in multiplication here. So y in the bracket, x and x cancel out, 1 plus log e raised to x. What is y? Y is x raised to x. So dy by dx is x raised to x in the bracket 1 plus log e raised to x. Same way, similarly, we'll apply here y raised to sine x into cos x. So again, log e we apply. We can write log also, simple log. Is it? Log e raised to base is, if we write log, only log, we can understand that base is e because it is a natural log. So log e raised to y is equal to log e sine x upon cos x. Cos x will come in multiplication. So log e raised to y is equal to cos x into log e raised to sine x, or we can also say log sine x. Okay, again differentiating on both the sides, what you get? Y. Is it? What is the derivative of log y? 1 upon y, and you have to take the derivative of y. Y is what? Dy by dx plus this u into v form. So y will be x, cos x is a constant. We have to take the derivative of log sine x. Log sine x is 1 upon sine x. And what is the derivative of sine x? Cos x. So you will get cos into cos x upon sine x. Now next time, what will keep constant? The logarithm function will keep constant and will take a derivative of cos x. Cos x is what? Minus sin x. So minus sin x into log e raised to sin x. Is it? Minus sin x plus minus sin x log e raised to sin x. So plus into minus minus. What is cos upon sin? Cot x. So dy by dx, this will go in multiplication. 1 upon y will go in multiplication. Y cos x into cot x minus sin x log e raised to sin x. Is it? Okay, you'll substitute the value of y. So what will become dy by dx? Dy by dx will become sin x raised to cos x in the bracket cos x sin cos x into cot x minus sin x. Is it? Into log e raised to sin x. Is it? Okay, fine.